Hello, everyone. Thanks for joining us today. My name is Kaylee Mata, and I work for the Aerospace and Defense Group at PTC. Today, I'm being joined by one of our partners, Joe Gelordi, CEO of Victorna Systems. We're going to be discussing next-generation training with augmented reality. For those of you who are not familiar with PTC, when I say PTC, I really mean the power to create. We're a technology company and are leaders of industrial digital transformation. We help our customers capitalize on digital technologies to advance their performance in the physical world and really transform how they do business. We started out over 35 years ago with CAD and then PLM. We later adopted IoT and augmented reality platforms. We are a US firm based out of Boston, Massachusetts, and we operate throughout the globe with around 6,000 employees and over 30,000 customers. We are a $1.4 billion company, and a good chunk of that comes from the aerospace and defense industry. Now, before we get started, I wanted to give a broader overview of AR and how it relates to challenges within the industry. One of the largest challenges is a growing skills gap. While there's been an ongoing effort to recruit new workers and to really close this gap, it can take years to get new airmen up to speed and to reach that level of proficiency that's needed to get the job done. Even with improving retention rates, some skilled airmen are still leaving the workforce, and a lot of times they can be taking some of that tribal knowledge with them. With these workers leaving, it can also lead to a shortage of qualified supervisors and a high trainee to trainer ratio. Safety is always a top concern, not only for new airmen, but for everyone. Anytime an aircraft takes off, it's a matter of life or death. And when you talk about safety, it's not only important to be talking about identifying and diagnosing existing problems with equipment, but it's also necessary to have the skills and experience to be able to identify potential hazards that might happen down the road. Outside of the equipment, it's important to have proper education about some of these hazards and the working environments to reduce the injuries on the job. Lastly, talking about operational concerns and workloads. How do you increase productivity, decrease downtime, and really boost morale? So how can AR provide that next generation of training? When you look at most existing training programs today, they're done throughout a combination of classroom environment, textbooks, or even watching trainers complete a series of tasks. Sometimes it can be a one-size-fits-all environment, and we all know that not everyone learns at the same speed or even with the same techniques. With the use of augmented reality, we can change the way we capture and communicate this information and knowledge. Being able to review training material in an engaging and structured environment has proven to increase knowledge retention as well as reduce training time. It provides a hands-on experience that you can follow at your own pace, and a lot of people find it fun to work with these technologies. Unlike virtual reality, AR allows you to get that hands-on experience. You can pick up the parts and tools and really get a feel for how they work. Working through these exercises allows users to develop their skills faster and to train in an interactive environment that can sometimes be difficult or expensive to create for training. Here you can see this experience is showing a breakdown of different systems within the aircraft. It provides a clear visual of how they operate and are connected. While this example is shown in relation to the physical aircraft, it's possible to create these experiences that are fully augmented. This is great if you don't have equipment available for training. That way, trainees can go through the augmented experience and really start to learn before they get into that hands-on situation. Here is an example of a systems check guided by augmented reality and connected with IoT data. As you can see, this alert is notifying the user of any potential warnings or hazards before they perform the inspections. As the operator is running through the checks, it alerts them that the tire pressure is low. It can then take you to guided work instructions on how to fix or replace the tire. The ability to easily find and access these instructions minimizes disruption by not having to go look for the instructions in a manual or having to go find someone who knows how to change the tire. Here are some of the key use cases of augmented reality that are not only being used throughout aerospace and defense, but throughout our entire customer base. I'm going to walk you through some of the benefits of each and show you examples. Remote assistance is not a new concept, but it's really expanded in the past year. The power to remotely connect skilled technicians to the field can fast-track problem resolution as well as increase uptime and operational efficiency. This is especially true when we're talking about a repair needed in a remote location or maybe somewhere that a third-party vendor cannot access. With these tools, you no longer need to send the subject matter expert on site every time there's a problem, allowing them to cut on their travel time and connect with more users in the field. In the field, the operator can either use a cell phone or a headset if they need both hands to work. Remote experts can use cell phones as well, tablets, or a desktop computer. In this example, we're going to go through a scenario where there's an operator in the field who has run into some issues with their vehicle. They really aren't sure what's going on. It looks like the suspension might be damaged. They've never run into this problem before. The part number is a bit hard to read, and they aren't really sure what part needs to be ordered now for the repair. With remote assistance, they're able to share their live feed with a technician and communicate with them. As you can see, the tech is actually leaving notes and mocking up the screen for the operator to help guide them. The operator can also go ahead and leave annotations. You can see as they move the phone around, the annotations stay where they're drawn. It's a very simple use case, but also a very powerful one. 3D instructions provide clear directions that help users understand exactly what to do and where to do it. At the same time, these users can provide feedback from the front line to help with traceability, compliance, and continuous improvement. You can easily create and scale these experiences with existing 3D models, and if you don't have any available, you can create one through reverse engineering. These instructions improve processes and help users get a better understanding of what to do. Being able to follow those instructions at your own pace and even being able to repeat steps has been proven to be beneficial to trainees. In this example, we're going to look at a fully augmented Lycoming 360 engine. We actually worked with them to help develop this experience. It takes an operator through steps on how to conduct certain service procedures on the engine, and you can see different configurations as you go through and change the options. You can add and remove pieces as necessary, which really helps in terms of identifying and becoming familiar with the parts. Similar to the example earlier, this can be overlaid onto the physical engine itself. Parts may also be animated to give a better understanding of the different aspects of the engine and how they operate. 3D instructions can be used for complex assembly procedures or even repair procedures. Seeing everything pieced together can help trainees get an idea of how the engine fits together in all three dimensions. There's also the ability to rotate and move perspective as needed based on the view that you need. We can layer in traditional information into the experience. If you have any PDFs, 2D drawings, or previous work orders, it can really create that bigger picture for the person servicing the equipment and make their job as easy as possible. Taking the last example a bit further, you can enhance your 3D experience by including IoT data. That data can really provide crucial information and more visibility into what's going on inside of the equipment. Being able to easily and quickly identify problems reduces time spent on troubleshooting and allows for a faster turnaround time. This data helps empower workers, enhances their decision-making, and can improve their confidence. Visibility to the performance data prior to the service can also give you a better idea of what procedures need to be done and allow you to properly order parts in advance and schedule out workers accordingly. Oftentimes, this can be used in manufacturing settings like you can see here. A system like PLM is really good at providing model-based work instructions for the factory. And then if you combine that with IoT platform, you can really create a highly interactive instruction that allows the operator to easily follow along with minimal interruptions. You can see here that it's highlighting the bins that the operator needs to pick the parts from, ensuring that they use the right parts. Of course, some of these washers and screws look alike, so having that identifier can really make a difference for someone with less experience. You can also leverage the use of smart tools. So if a torque value is delivered to an assembly, it can easily be measured and stored. Here you can see it passes. These instructions may also be delivered in a more interactive way. With complex procedures, the 3D instructions can be easier to comprehend and faster to work through than following 2D instructions. Here it is showing the information on the part as well as the work orders. This really allows operators to prepare beforehand and even practice procedures before they get to work on the physical parts. It allowed for easy identification to where the attachment parts are and provides the ability to watch full assembly, even allowing them to re-watch some steps more than once if they need to. That way, when they conduct the assembly themselves, there's very little risk of them assembling the device incorrectly or even damaging the part. AR can play a really big role in making sure that they can not only prepare but get the procedure done correctly the first time and every time. Delivering work instructions to frontline workers is one of the most valuable applications for augmented reality because it enables relevant digital content to be presented directly in front of the user's field of view when and where that information can be most impactful. Sometimes it can be difficult to capture that information. After you do capture it, you need to figure out how to make that information easy to consume and figure out where to store it. And it's also to make it easily accessible for everyone. A lot of times procedures do change, and then adding or editing some of those procedures can also be like recreating the wheel. We have several customers that are using our AR solution for this, but for this example, I wanted to discuss a training pilot that was created for Kirtland Air Force Base by our partners ILW. This group maintains special operations tilt rotor aircraft, and they were able to implement this technology as a way to train some of the new people in the squadron and teach them some of the common tasks around the aircraft associated with line maintenance. As you can see, these are hands-free instructions that don't require searching in a manual and can allow them to quickly identify what is needed and how to do it. They were very successful with this program, and with this technology, along with other implementations, they were able to improve their training times by almost 20%. The group actually received several awards within the Air Force for the work that they have done. And now I'll hand it over to Joe Gilardi from Vectron Systems, and he'll be talking about some of the training programs that they worked on recently with augmented reality.
Thank you, Kaylee. It's a pleasure to be here with you today, and thanks for all of you for joining us on the web. Now, I'm a systems engineer by background, but before founding Vectrona, I had the tremendous opportunity to serve 23 years in the Navy, during which time I spent a lot of it performing some complex tasks that were made profoundly more manageable through the power of augmented reality.
Joker 207 3/4 mile on course on glide ground protocol.
207 on a ball, 42 auto.
Roger, ball auto, 23 knots.
Now, the heads-up display in a fighter is a tremendous augmented reality tool, and you can see that it's delivering a great deal of information to the pilot precisely when and where needed in an easy-to-consume way that enables them to perform a complex task consistently, repeatedly, and safely with a high-performance outcome. This is incredibly valuable, and what we get very passionate about here at Vectrona is the opportunity to help other teams and other organizations use the power of mixed reality and data visualization to achieve greater outcomes in the performance of their complex tasks. Now, I'd like to share just a little bit with you about who we are at Vectrona, how we approach our problems, talk about our great partnership with PTC and the powerful tools that they offer our solution. And most of the time we'll spend talking about a case study for work that we've been doing with the Air Force for the last several years. Now, here at Vectrona, our team is made up of an interdisciplinary group of engineers and technologists and software developers, with many of us also with operational backgrounds to understand the tasks performed from the user perspective, as well as being able to pull in the science and technology components and be the architects of the final solution. Now, one of the keys to having a successful solution is using a user-centered design principle that holistically considers the people, processes, and technologies that together will deliver the solution. Because if you primarily just look at the technology piece, then you're going to sub-optimize the system, and you're probably going to be disappointed with the return on investment that you're afforded. We are leaders in live virtual constructive training, providing high-risk tactical training for the Navy, as well as human intelligence training, cybersecurity training, aircraft, pilot weapons and maintenance system training, as well as air battle management training for the National Guard. Partnership with PTC, as I said, has been incredibly valuable to us. And we're also proud to have been a finalist in the Partner Award for Innovation Trailblazers in the last calendar year. But let's dive into this use case of analyzing performing a digital transformation for U.S. Air Force weapons training, where they challenged us to explore solutions to three main capability challenges that I believe will probably resonate with many of you in your organizations. How do we improve readiness despite realistic resource constraints? How do we improve and overcome experience and knowledge loss due to aging, retiring, and transitioning workforces? And then how do we achieve greater training effectiveness and knowledge retention among our workforce so that when they show up to do the task, they don't need as much on-the-job training, which sort of turns into a double tax on the organization because now you have operationally qualified folks who are removed from production to spend more time training to get these new members of the workforce fully up to speed to contribute. Now, we've found the same basic gaps exist in the shipbuilding industry, and we're starting a new digital transformation effort now in the U.S. nuclear power industry where the same identical challenges exist. So I believe that they probably, as I said, will resonate with many of you. Now, how do we approach the problem? Well, we conducted holistic capability gap analysis and discovered 3 primary training capability gaps that existed in the schoolhouse that we focused on for this aviation maintenance weapons training. And those are lack of physical training assets to train on that can be very costly to acquire and then maintain, insufficient time available to learn what are some truly spatially challenging concepts and systems and principles, as well as a lack of performance data to tell us both about the effectiveness of our individual's performance as well as the effectiveness and performance of our systems and our curriculum. And this is the most challenging in legacy systems that were not organically designed with data in mind. And so what we did then is optimize our augmented cognition environment system and tailored it to address specifically those gaps. And we did this again using some powerful PTC tools that help us do several things. We use the Creel Illustrated tool to help sort of feed that digital thread at the front end of the system and pull in some, through the help of some CAD data and other resources to feed the system to help support content authoring and editing. As we move into training delivery management, we use the Vuforia Studio suite of tools that helps us deliver mixed reality and augmented reality solutions. And we also leverage the ThingWorx data platform as the backbone for all of this information to ride on. As we move through the system lifecycle and move into operational environments, we'll show you how those mixed reality experiences become task performance aids that not only are leveraging the information in the digital thread, but are also adding to it with user-generated content that will feed the fidelity of the data as it moves upstream. So we begin this task by, in the schoolhouse environment, by activating legacy environments that are typical, flat, 2D, instructor-led, death by PowerPoint type of learning environments that nobody really cares for. And we try and activate those and supplement them with a data operating system agnostic solution, something that is powerfully enabled by the Vuforia suite, system that can work in network connected environments or offline if there are resource or security constraints, but also with an easy to use UI UX that makes it very quick for users to kind of get an out-of-box experience where they can dive right in and start training. And so what do these kind of experiences look like? Well, this is a mixed reality capture from a HoloLens 2 tutorial experience in which the user is learning here about the M61A1 cannon as it is installed in the F-16 Viper aircraft. And you can see that they're experiencing multi-domain learning, that they are being fed with oral cues, with a voiceover narrative, with instructions that they can read, with an interactive, spatially realistic scene that's delivered in their own environment, that they can move around, that feels very natural. And the experience is very rich because it's touching on all of those senses, and that multi-domain information is creating memories that are very complex because they have lots of different data that's attached to them. This content, of course, can be used because of the network capability anytime and anywhere. And because the student is being provided with information in so many forms, they have the ability to utilize the information that most fits their learning style, which is going to create a more effective learning environment. So with initial learning sort of concepts introduced, then you also, of course, want to have a check on learning to identify the effectiveness of your system and how well your students are learning. So we can also do that with mixed reality quizzes and practical application exercises that will challenge users to not only assess their knowledge, but also in a gamified way, create and tap into this competitive nature that all of us have, where we are now intrinsically motivated to improve our performance, improve our score, improve the score of our peers. Now, this experience that we'll take a look at is designed for a handheld device that in some cases, in some environments that are more physically constrained, is a little bit easier to use in a classroom, but you can see it's still an interactive mixed reality experience that allows the user to be sort of challenged in the information and knowledge in a way that is very relational to their real operational environment, and they can experience that data in the way that's consistent with the way they'll use it. What this does is it helps to, again, create a stickier learning that will have greater knowledge retention due to the complex nature of the information that they're being faced with. As we now move into the actual performance of tasks and inspections, we can feed those with experiences that do a lot of things for us. And we'll first look at a demonstration of a safer maintenance inspection performed on an F-16 Viper aircraft. And here you can see that the user is fully immersed in this virtual environment, but they're still connected to their own physical environment. They can interact with their peers while they're interacting with the experience, but they get to do it in a very natural way. That is, again, providing them wayfinding information, instructions, safety, hazard information, and it's going to be directly relatable to how they're going to perform the tasks in real life. By using mixed reality, one other benefit is that we can free up assets that could have been used, perhaps in this case, an F-16 aircraft. Instead of having to dedicate one to training, you keep it out on the flight line where it's actually performing operations, and allow the students to perform their learning for new students, or perhaps for more senior individuals to perform cross-training. And this, of course, is also going to be a much safer environment. Now, as we move into performance of real tasks, we can also use model target-based experiences to now deliver all this metadata on top of an actual physical environment. Now, they don't really like us to have live 500-pound bombs in the building, so we use scale models such as this 1/3 scale GBU 38 500-pound GPS-guided bomb. But through the use of the model target, what we can do is we can actually anchor the virtual environment on top of the physical environment, and then deliver wayfinding, instruction, and safety information to the user to help them walk through the performance of the actual task. And then the data that can be generated within the experience can tell us how well the task was performed. We can use it for verification and control that steps in the procedure were completed, and that information can in turn feed the digital thread to confirm completion of any range of critical tasks. So at the end of the project, to assess the effectiveness of all these things, we brought in our PhD research team, and we performed a side-by-side study of students that used the legacy technology versus those who were able to benefit from some, unfortunately, COVID-limited application of the A6R system in the conduct of their training. And we were extremely pleased with the results. And what we discovered was that those students that used the technology, even if it was only for 5 to 10 hours over a 6-week period, performed consistently superior way over the legacy students, achieving grades of a letter grade or higher more in their work. And it's clear to the researchers that with full utilization and implementation, substantially superior results will be achieved across the range of curriculum. One of the exciting things that we discovered that we didn't fully anticipate was that the system also broke down barriers to learning. It made what seemed very intimidating to be simple, and that got the students to dive right in and be not afraid of hurting themselves, embarrassing themselves, breaking some equipment that would disrupt the training. And that overall meant they spent more time training with greater confidence, with a higher level of motivation, with more engagement. It gave them more time to conduct real hands-on training to the result of a greater outcome. But let's get to the bottom line. Where's the opportunity to capture ROI across the full system life cycle? Well, the system can enable folks to enhance learning by simplifying the processes of content development, delivery, and standardization across a user enterprise. We can transform classroom and lab experiences so that students end up focusing more time on doing instead of just passively learning. As we move into an operational environment, we find that the tools can accelerate task performance and cross-training. We can use them to capture knowledge and use remote communications capabilities to bring in virtually experienced judgment when it counts to complete a task. And then we can use this as a tool to not only to create continuity through the digital web, but also to add new rich data and user-generated content to feed that and overall enhance the fidelity of our system. Now, we hope that all of this information has been valuable to you today. It's been a pleasure to have the opportunity to share a bit about our story with all of you. I hope that hearing about this use case was useful to all of you in assessing how you can address some of the own challenges that you face in your organization. And if there's anything we can do to help, we'd be happy to speak with you. And we look forward to taking your questions. Thank you very much.
Thank you, Joe. As Joe mentioned, we would be happy to help out with any questions you might have. Here's my email address if you'd like to set up a call or if you'd like to try out a demonstration. You can also check out our website at ptc.com for more information as well. Have a great day.